In this video, we'll look at how to interpret an iterated integral as a double integral over a particular region and calculate it. I'm looking at the integral from -1 to 0 and 1 to 2 of the function x squared, and the order that I write these differentials in is very crucial. It tells me how to interpret the limits of integration. Let's draw a picture first. The outer limits, dx, tells me that x range from -1 to 0, so I'm going to get an inequality there for x. And then dy ranges from 1 to 2, so y is between 1 and 2. And if I draw those vertical lines for x, -1 and 0, and the horizontal lines for y, 1 and 2, and I shade that region in between, that's really calculating the double integral over that little rectangular region that I've shaded in. To calculate that, I first calculate the inner integral. So I think of y as the variable and x as a constant, so x squared is treated as a constant, and I integrate with respect to y to get x squared y, and I need to evaluate that from 1 and 2. 1 and 2 are values of y because we were integrating with respect to y, so everywhere I see 1, or y, I plug in 1, and everywhere I see y, I plug in 2, and I plug those two expressions in, and I subtract the answer. I now simplify this expression, so 2x minus x squared is x squared. And I integrate that with respect to x and evaluate that between -1 and 0, and plugging in those two numbers gives us positive 1/3. An important lesson here is that the order of integration matters. If I arbitrarily just decide to change the differentials around and write, instead of dy and dx, write dx and dy, I'll have a very different, potentially very different answer because I'm calculating a different volume or different double integral. Now, my y values are ranging from -1 to 0. My x values are ranging from 1 to 2. And that's a very different rectangular region. I'm looking at those two vertical lines for x equal to 1 and 2. And y is -1 and 0 is giving me some rectangular region in a different quadrant now. Integrating that is probably going to get a different answer. When I integrate x squared with respect to x, I get x cubed over 3. I evaluate that between 1 and 2. That gives me a constant. In this case, it gives me 7/3. And now I integrate that with respect to y and evaluate that between -1 and 0. And I plug those numbers in, and you can see here I get a different answer. That's because it represents something different.